Hey everyone, Kotowane the Native God here. Today we'll be looking at a problem based on reduction in gearboxes, right? And it reads as follows. A 3-speed riveted gearbox is shown in figure 2.14. It must provide the following gear ratios. First gear approximately 3.6:1. In second gear it's approximately 2.27:1. Then in third gear, of course, when the input meshes with the output, the gear ratio is 1:1. The gear ratio of A and B is equal to that of E and F. The sensor distance for all the meshing gears is the same. Now, they didn't really need to mention that because remember, with riveted gearboxes, the input shaft is coaxial with the output shaft, right? And parallel, and also both shafts are parallel with the lay shaft, right? The lay shaft being this one here, right? And the center distance, so the center distance between the output shaft and the lay shaft is the same as the center distance between the input shaft and the lay shaft, right? So if we're looking at a riveted gearbox, such is always the case, right? So they didn't really need to mention that the center distance for all meshing gears is the same, right? The module for all the gears is 5 millimeters, and gear A must have 18 teeth. Find suitable numbers of teeth for all the gears, as well as the sensor distance and the exact gear ratios, right? So we already have the number of gear teeth for gear A. Now we need to find the number of teeth for the other gears. So your B, C, D, E, and F, right? So the way we are going to do that is by looking at the gears that mesh in each gear, right? So meaning in first gear, we look at which gears mesh, and in second gear, we look at which gears mesh, right? And of course, in third gear, we know that the output shaft meshes with the input shaft, right? Now, with reduction in gearboxes, right, what we try to do here is to move the output shaft, right, from where it is to meshing with the input shaft, right? So we are in this case looking at a 3-speed riveted gearbox, right? So the way we go about doing this is in first gear, right? In first gear, we look at the gears at the back of the output shaft and the gears at the back of the lay shaft, right? So in first gear, you have the gears that are in constant mesh, which is your gear A and gear B. Those gears are in constant mesh regardless of which gear has been engaged, right? And then in gear 1, you have the gears that's in constant mesh, and then you look at the gears on the output shaft and the gears on the lay shaft, right? So the gears at the back of the output shaft and the gears at the back of the lay shaft, right? So in first gear, those are the two gears that are going to mesh, right? So you have the gears in constant mesh, and then E and F are also going to mesh in first gear. And then in second gear, you still have the gears that are in constant mesh, so A and B, and then the other gears that are going to slide into mesh are going to be what? So you look at, in second gear, you look at the second gear from F, right? So on the output shaft, what is the second gear from F? The second gear is gear D. And then you look at the second gear on the lay shaft from E. And the second gear from E on the lay shaft is what? Is gear C. So in second gear, those are the gears that are going to mesh. The gears that are in constant mesh and the gears that are going to slide into each other are C and D, right? So again, in first gear, you have A, B, and E, F. And in second gear, you have A, B, and C, D, right? Right, now let's see what that looks like. So let's first look at first gear. So we're first going to look at for for first gear, right? Now, as mentioned, in first gear, these are the gears that are in mesh, right? So these are the gears that are in mesh. Gears A, B, which are in constant mesh, and then EF, right? So the gears that are represented by the color orange are going to be our input gears, and the gears represented by the color blue are going to be our output gears, right? Right. Now, remember what we have here. They said gear A has 18 teeth, right? And we're looking for the other gears, or the other teeth of the other gears, right? What else have we been given? Now, they said for first gear, the gear ratio is approximately 3.6:1. Now, what does that mean, right? In first gear, these are the gears in mesh, right? So A, B, and EF. So when looking at the entire gear system, the gear ratio is going to be equal to what? It's going to be equal to, now remember, in terms of gear ratio can be expressed in terms of the rotational frequency. It can be expressed, it also can be expressed in terms of the number of teeth, and it also can be expressed in terms of torque, right? So in terms of rotational frequency, right, we have N in, so the rotational frequency of the input shaft over the rotational frequency of the output shaft, right? That is in terms of the rotational frequency. In terms of the number of teeth, right, it's number of teeth of the output over number of teeth of the input. So you could just simply say vice versa of what? It's vice versa of what we have on the rotational frequency, right? Now, how can we put this in terms of the gears that are meshing in first gear, right? So gear ratio is going to be equal to what? Input shaft is on gear A, so this will be NA over N out. The output shaft is connected to what? To gear F, so this will be NF is equal to T out. Now, like I said earlier, the orange represents the input gears and the blue represents the output gears, right? So for T out, we have TB times TF over the input, so TA times the number of teeth of gear E, right? And the gear ratio, they've given it to us. They said for first gear, the gear ratio is approximately 3.6:1, right? So all of this, the gear ratio is equal to 3.6:1, which is the same as over 1, right? Now we are looking for the number of teeth, right? So we are going to use the gear ratio that is expressed in terms of number of teeth. So let's use, so TB times TF over TA times TE is equal to 3.6, right? Now, what else have they told us? Now, they also told us that the gear ratio of A and B, right, is equal to that of E and F, right? Is equal to that of E and F. Now, what does this mean, right? When looking at just meshing gears, right? So we know that in the first gear, A is meshing with B and F is meshing with E, right? So we're going to look at the gear ratio for just the gears in mesh, right? Now for gears in mesh between A and B, right? In is A and B is out. So in terms of gear ratios, right, when just looking at A and B, we know that NA, which is in, over NB, which is out, is equal to TB over TA, right? And then when looking at meshing gears F and E, right, F, remember, is out and E is in, so meaning in terms of the gear ratio, right? So this is the gear ratio for gears A and B. Then the gear ratio for gears E and F, it's NE over NF is equal to what? So this is TF over TE. So this is the gear ratio for what? This is the gear ratio for meshing gears E and F, right? Now, they are saying gear ratio A and B is equal to that of E and F. What does this mean, right? So we're just gonna use the gear ratios which are in terms of number of teeth, right? So this means that if gear ratios of A and B are equal to the gear ratio of E and F, it means that TB over TA, which is the gear ratio for A and B, is equal to TF over TE, right? Right. Now, this is the information they gave us, that the gear ratio of A and B is equal to that of E and F. Right? Mathematically, we express that in this manner. Right? Right. Now, going back to our gear ratio for the entire gear system, right? We know that our gear ratio for the entire gear system is equal to this, right? Now this we can also rewrite it like this, right? So TB over TA times TF over TE is equal to 3,6, right? So we agree that this here is the same as that, right? Now, going back to this relationship, right? They said the gear ratios of A and B is equal to the gear ratio of E and F. So TB over TA is equal to TF over TE, right? Now, mathematically, in order for us to get 3,6, right, for the gear ratio of the entire gear system in first gear, right? Since now we know that TB over TA is equal to TF over TE, it means that to get 3,6, we can simply just use the square root of 3,6 times the square root of 3,6, and that will give us 3,6, right? Now what does this mean? This means that therefore TB over TA is equal to what? The square root of 3,6, right? And then also TF over TE is also equal to the square root of 3,6, right? Remember, they said TB over TA is exactly equal to what? TF over TE. That's why mathematically we are able to do this, right? Now, TB over TA is equal to the square root of 3,6 is equal to 1,897, right? So now to get TB, remember they gave us TA, right? TA is equal to 18 teeth, right? So to get TB from this, you simply have to cross multiply, and then TB will be equal to what? 1,897, TA. So TB is equal to 1,897 times number of teeth of gear A, which is 18 teeth. So TB is equal to what? If you punch that in your calculators, you're going to get 34,146, right? And then you round this off, right? When you round this off, you're just gonna get 34 to get your number of teeth, right? So TB is equal to 34 number of teeth, right? So we have the number of teeth of TA of gear A, and we have the number of teeth of gear B, right? To get the number of teeth of E and F, right? Now the simple way of doing this, right? I'll show you the long way, but let me show you the simple way of doing this, right? So in this case, they told us that, remember, in this case, they told us that where is this? They told us that this is what we know. This is what they told us, right? This is what they told us. Right? That TB over TA is equal to TF over TE, right? Now TB over TA, right? We just calculated TB, so TB is equal to 34, TA is equal to 18, right? So TB over TA is equal to this, and then also TB over TA is also equal to what? TF over TE. So TE, right? If that's the case, if TB is equal to 34, then it means that TF is also, then it means that TF is also equal to 34. And then if TA is equal to 18, it means that TE is also equal to what? 18. Right, so we can draw a conclusion here because of the relationship that they gave to us, that TB over TA is equal to TF over TE. Mathematically, that comes to TF being equal to what? To 34 number of teeth, and then TE, right, being equal to what? 18 number of teeth, right? For the reasons I've just stated, right? That is the short way or the simple way of looking at this, right? The long way of doing this, right? If you're going to be looking at the long way of doing this, right, we first need to calculate what? The sensor distance, right, between the input shaft and lay shaft, or output shaft and lay shaft, right? Remember, this is a riveted gearbox, meaning what? Meaning the input shaft is coaxial with the output shaft, making the sensor distance between the input shaft and the lay shaft and the output shaft and the lay shaft equal, right? So meaning if you can get the sensor distance of the between the input shaft and the lay shaft, you inadvertently get the sensor distance of the output shaft and what? And the lay shaft. So when I refer to the lay shaft, this is the lay shaft, right? So we need to get the sensor distance being this one, right? Sensor distance being this one. So for riveted gears, the sensor distance is equal, right? So if we can get the sensor distance between the input and lay shaft, we'll get the sensor distance for between the output shaft and the lay shaft, right? Now, the sensor distance, what is the sensor distance equal to? M into, so when just looking at the input shaft and the lay shaft, right? So we have gears A and B for the input and lay shaft. So TA plus TB over 2, right? So C is equal to the module they gave to us. They said the module is 5 millimeters, right? So take our module as being 5 millimeters. So this is 5 into TA has 18 teeth. Then TB we just calculated. We got 34 teeth over 2, right? And then if you punch this in your calculators, you're going to get 130 millimeters. That's the sensor distance, right, for this gear system, right? Right. Now, we already established that TF over TE is equal to what? Is equal to 3, the square root of 3,6. The square root of 3,6 is equal to what? 1,897, right? So meaning we can say TF over TE so over TE is equal to what? 1,897. So to get TF, just simply cross multiply. So TF will be equal to 1,897 TE, right? Right. So we take this as our equation 1, right? Take this as our equation 1, and then we also know that in terms of the sensor distance, right? Now when looking at the sensor distance between the output shaft and the lay shaft, right? So in terms of, or between the output shaft and lay shaft, right, the engaged gears are what? Are gears E and F, right? So the sensor distance is also equal to the module into TE plus TF over 2, right? Now we have the sensor distance is 130 millimeters. The module is 5 millimeters for all the gears into TE plus TF over 2, right? 5 over 2 is 2,5. So we have 130 is equal to 2,5 into TE plus TF, right? Then you divide both sides by 2,5, 2,5. Therefore, TE plus TF is equal to what? 130 over 2,5 is equal to what? 52. And you take this as your second equation. All right. Now we're going to sub the first equation into the second. So sub equation 1 into 2, right? Equation 1 is in terms of TE. So TE plus the 1,897 TE, which is equal to TF, is equal to what? 52. Right? When you add this up, you're going to get 2,897 TE is equal to 52. Right? You're looking for TE, so we divide both sides by 2,897. So TE 52 over 2,897, if you punch that in, it's going to be equal to 17,95. And rounding this off, because we're looking for number of teeth, we're going to get 18 number of teeth, right? Now, if you look at this, this is exactly equal, right? If you look at this, this is exactly equal to what? To the number of teeth of gear B, right? So like I said, there's a much simpler way of doing it, which I showed you, right? But if you wanted to prove that, this is how we prove that, right? So let's get now the number of teeth of gear F, right? They should be equal to the number of teeth of gear B. So gear E, the number of teeth of gear E are equal to the number of teeth of gear A, right? So meaning TF, or the number of teeth of gear F must therefore be equal to what? To the number of teeth of gear B, right? This is from this relationship, right? Like I explained earlier. So let's calculate now the number of teeth of gear F, right? So we're going to use equation 2. So we know that from equation 2, TE plus TF is equal to what? 52. We are now looking for TF, which is equal to 52 minus TE, right? So TF is equal to 52 minus 18, right? Which is equal to what? 34 number of teeth, right? So as far as number of teeth of the gears engaged in first gear, we now have all the number of teeth of the gears, right? This one has 34 number of teeth, right? And then this one has 34 number of teeth as well. And then gear E has 18 teeth, right? So that is for first gear, right? Now, for the other number of teeth, which we'll find when looking at what happens in second gear, right? For that video, stay tuned. That video will follow in this series, right? See you in the next one.